How does AI work? Let's take a look at one technique, one model that's used today in artificial intelligence, and that's artificial neural networks. I'm Professor Gary Locklear, and thank you for joining me again as we take a look at this fascinating topic of artificial intelligence. While this is the fifth video in the series, you certainly don't have to watch them in that order. And as I go through and modify things, they may be in a different order as we come back to them. What is this idea of artificial neural networks? Well, in a nutshell, rather than having to explain to a computer how to do the job, which can be a very difficult process, we get the computer to learn itself how to do the job. You say, how can a computer learn? Well, one technique, the one that we'll be investigating today, uses something called artificial neural networks. We model the human brain, which is made out of neurons, using artificial neural networks. And let's investigate how a Christian worldview can help us navigate the workings of artificial intelligence and artificial neural networks. By way of review, what is artificial intelligence? Here's some comments that I've been sharing with you. So, what is AI? First of all, artificial intelligence is human attempts to fashion intelligent entities. Now, today in the 21st century, those entities are computer systems, and we want computer systems to act on their own. So we'll refer to those as autonomous computers acting with plan and purpose. Plan and purpose are indicative of intelligence. Or a way to describe AI is computers performing actions that would require intelligence to do. Intelligence. Some time ago, I attempted to learn a little bit of German for a research project. My wife knows some German, and I was working with the German professor at our university. And she said, one way you can know if you really understand the language is if you can get jokes in a language, because they're really hard. Okay. So she asked me, why is a German stone intelligent? I said, I don't know. She says, because it's not just a stone, it's Einstein. Well, if you're German, you understand Einstein is stone, and then you probably caught Einstein there also. Let's review some things we've seen in previous videos in this series. Artificial intelligence encompasses many different spheres of research today. And one huge area of AI research is something called machine learning. We're going to take a dive into how that works today. In the past, in the 20th century, we talked about machine learning, and then there was a breakthrough that we will discuss today. So now with this breakthrough, we refer to what's happening as deep learning. One aspect of deep learning is a family of AI techniques and tools called generative AI. It will generate new information. And a subtype of generative AI is a large language model, or an LLM. There are other types of generative AI that don't deal with language, like with images, so there'd be a large image model. But you're familiar with one large language model, at least one that I have shown you in this series, and that's ChatGPT. There are other ones, but all these current things that most people are aware of, and when today in the mid of the 20th, hello, what century is it? Is it? In the mid 21st century, when we think about AI, we think about ChatGPT and other similar chatbots. How does that work? How does ChatGPT work? Well, if you ask that question, you're really asking two separate but related concepts. Number one, how is it set up? How is it created? We saw these steps at a very high level before, too. Data pre-processing. When ChatGPT, it works with words, but the words are not whole words in English. They are tokenized. The words are changed into parts of a word, and then they're all assigned a numeric value. Just makes processing easier. And then this we've seen before, and we'll talk about today again, training the model, identifying patterns, probabilistic data generation, and then I have my model ready to go. So once the model is created, like ChatGPT, then folks work with it. But the interesting thing about neural networks is working with it also changes it. It's a way it learned at the beginning, but this is now an additional learning aspect. So you run ChatGPT, it takes our input, our question, it encodes it, has to change it into tokens and numbers, and then goes through this process using something very similar to an artificial neural network in order to get a response back out. Question: how does ChatGPT work? Oh, well, honestly, we don't really know. Is that shocking? AI researchers, the computer scientists who create these tools, can't truly tell you how they work inside. Oh, yes, at a high level, we'll all say they use ANN, artificial neural networks, to process. But here's a quote from a group of researchers working on a different AI model called Claude. Large language models aren't programmed directly by humans. Instead, they're trained on large amounts of data. For training, we would use the word learning. During that training process, they learn their own strategies to solve problems. They learn their own strategies to solve problems. These strategies are encoded in the billions of computation a model performs for every word it writes. They arrive inscrutable to us, the model's developers. This means that we don't understand how models do most of the things they do. Computer scientists don't know how artificial neural networks, large language models, and much of AI works internally. Many AI systems, including large language models like ChatGPT, use artificial neural networks as the basis to do their processing, to solve the problem. We give it input, it goes through artificial neural networks, and it produces output. An artificial neural network models the brain, at least many people think it does. The assumption, and we got to investigate this assumption, is that thinking is totally dependent upon the neurons in our brain, which many AI researchers would say is a naturalistic, materialistic process. Well, honestly, we don't know how the brain works internally, and we don't know how artificial neural networks process data. Oh, yes, I teach the subject and I can say there's all these things, and we'll see a little bit about it. But after they're trained, how did they decide? How did they do this thing? We really don't know. When I was discussing the brain one day in class, a student got up, held his head, and said, "Oh, my head is whirling." And I said, "Ah, of cerebral vortex." A cerebral vortex? I imagine this is surprising that we really don't know how this works. We're going to talk about a reason why being these are not algorithms that we tell it what to do. We're asking the machine to learn, and we're not really sure how it does that. Let's review. In a previous video, we talked about the idea of algorithms, and we looked at a very important AI algorithm, and that is machine learning. But in the bad old days of AI, during AI winter, the second half of the 20th century, from the 1970s to the end of the 1990s, we were trying to tell computers how to solve the problem. Whether that problem dealt with detecting faces in an image or playing games, we were attempting to tell the computer explicitly how to do this. This proved to be very hard. The big word is intractable, extremely hard to do. Trying to tell a computer via an algorithm what a face is for a face detection system is extremely hard. You know, as a college professor, I wish that I had name and face recognition installed. I have a hard time remembering names and connecting them to faces, right? But AI researchers decided, and this was the end of AI winter, the beginning of the 21st century, that rather than explicitly telling a machine how to solve the problem, it would be better to have the machine learn by itself how to solve the problem. So you probably think identifying a face in an image is easy, and it is easy for us as designed heuristic problem solvers. But trying to explain a face algorithmically is hard. A classic example, detecting a face versus a blueberry muffin. The muffin that had the blueberries arranged like eyes, nose, and a mouth. Yeah, it turned out to be very hard for a computer system. So rather than explicitly telling the machine how to solve the problem, it would be better if the machine itself learned by itself how to solve the problem. And since humans can learn and humans have brains, would it make sense to model the brain and have the computer learn that way? Perhaps, AI researchers felt, we can understand and model the brain as a technique to get computers to learn. Now, investigation into the human brain is very old. I mean, the Greeks thought about this even before the time of Christ, but it really wasn't until the 19th century when we had the scientific tools like a microscope and other things to try to investigate the brain and brain activity. William James, who lived and worked in the 19th century as American philosopher, really set the stage for the modern science of psychology. And William James is one of the first people to investigate and try to put together brain activity. In the 19th century, there were two schools of thought. One school was the neuron school, that there were a bunch of individual cells in the brain. These were neurons. And yeah, that's what we call these some of the cells in the brain today. Brain activity. So, what do we know? Now, you should realize that just like me, current brain researchers don't know everything and they make mistakes. The brain consists of neurons, nerve cells that carry information throughout our body. By the way, there are many more cells than just neurons in our brain. However, scientists estimate there are 90 billion neurons in our brain. Wow, that's a lot, right? Now think about this. When a baby is born, She has most of those 90 billion neurons. So that means that during development, while she's in her mother's womb, 250,000 neurons are created each minute. That is staggering, wouldn't you say? Now, it's not just that we have 90 billion neurons. That's complex enough. But the complexity of the brain comes up in the interconnections. Neurons connect to other neurons, and there's a little gap there called the synapse. Each neuron is connected to at least 1,000 other neurons. This is a web, and that's why we call it a network. The brain is immensely complex. You know, the brain is so complex, no wonder most people don't use their brain. Thanks for laughing along with me. So, how do neurons work? Now, today, again, we don't exactly know. We know some things from research. Here is a stylized model of a neuron and some of its components there. And here's where the synapse occurs, the axons going over to other dendrites of other neurons along the way. How do neurons work? Well, an individual neuron receives input from others in the network. Maybe not all 1,000, but many, many others. So each neuron gets input, a signal. And by the way, this signal can either be electrical or chemical. It works both ways. Neurons receive input from others in the network, and the signals will add up over time. As a neuron receives more and more signals, it is designed with a so-called threshold. And when it receives enough signals, when it goes above the threshold, that neuron will then fire. It will send either an electrical or chemical impulse along its axon onto other neurons. All these neurons are arranged in layers in a network. And unlike artificial neural networks, at least mostly today, neurons have various levels of strength, and that's usually determined by frequency, how often they will fire. They can do that relatively slowly or relatively quickly. Wow. Question. Oh, what do you call it when a normally very responsible brain cell goes out for a wild night on the town? A synapse of judgment. So here's the question that mathematicians and computer scientists of the mid-20th century asked. Could we model the brain? So could we model the brain's neural network in a computer with the ultimate goal of getting a computer to learn and be intelligent? Could we model the brain? In the middle of the 20th century, 1940s and 1950s, two researchers, McCullough and Pitts, set out to mathematically model what they thought a neuron was about. And this is it. Here's the neuron. Notice it gets inputs, and these inputs are weighted in some way. It receives these inputs, and then there's this threshold. When the inputs are summed up and it reaches above the threshold, then it will fire. It will output something. So here was the mathematical model developed in the 1940s and 1950s. And then computer scientist Frank Rosenblatt in 1957 created the first computer circuit called the perceptron that did this. And then the perceptron, they put a lot together and began modeling the brain. The perceptron was a single layer neural network and was capable of binary classification. It can answer some yes/no questions, but not very complex, to be sure. So this, in the mid-20th century, led to the development of ANNs, artificial neural networks. An ANN, an artificial neural network, is a machine learning technique. It's a machine learning model. Again, based on how we and many people believe the brain works and processes. Artificial neurons are these processing nodes, these processing centers, of which in a neural network there are many. How many? In current large-scale models, billions. Ah, okay. The network of artificial neurons comes from the interconnections, just like we know neurons, real brain neurons are connected. So you can see that this first layer neuron is connected to three of the input ones, and so it goes. The network comes from this interconnection idea of all the processing nodes. And of the interconnections, there are many, many more connections than nodes. So you see, here's the classic representation. An artificial neural network has an input layer where we give it data, an output layer where we receive the information, the answer, and then here's where all the interesting stuff happens, the so-called hidden layers, which actually carry out and perform the processing required here. Each node connects to others, and they send data on. So just like a human neuron, this needs to receive so much weight, and then it will fire and go along its paths also. Each node connects to the others, has its own associated weight and threshold. If the output of any individual neural network node is above the threshold value, then that node is activated and it sends a signal along to the next nodes in the network. If it's not above the threshold, no data is passed. If you care, each node here is similar to a mini linear regression model. Woo. Now, let me remind you of something important about me. I don't know everything, and I make mistakes. But a number of years ago, I'm trying to remember exactly when this was, the neurons are not firing here. I was invited to participate in the International Neural Network Association conference, University of Alaska at Anchorage. Alaska is a cool place in more than one way. I enjoyed my time there too. So, although I don't know everything about computer science, I do know some things. How do we do this? And you're saying, wait a minute, you said we don't know how they work. We know how to make them. We know how to make the model. But after it's trained, how is it? No, then we're not really so sure. So, how do we implement an artificial neural network today? Well, the difficulty of doing this, and this was the idea that many people had in the 20th century, but the difficulty was we didn't have the computing horsepower. We didn't have the computational ability to do many hidden layers. The best ANN models of the 20th century might have had 2, 3, or a very small number of hidden layers. You see, all these things have to happen at the same time. In computer science, we call that parallel processing. Most computers are fast, but they only do one thing at a time. And once you start having millions of connections, it just slows down and it can't be done. So the difficulty of implementing ANNs in the 20th century dealt with processing power. The processing power needed to implement a complex network with not only many, many nodes, but many, many more connections between those nodes. A breakthrough happened right about the turn of the 20th to the 21st century. The breakthrough came with the rise of GPUs. A CPU, central processing unit, runs the major algorithms of a computer system. GPUs are graphical processing units, and they were designed, well, let's give credit where it's due. Video gamers. Gamers demanded more and better graphics and things happening faster, etc. GPUs, graphical processing units, were developed as parallel processors. So they can do multiple things at once and update every little pixel on the display at once. Yeah, thank you, video gamers. Are GPUs useful for other things? They are. Because GPUs are parallel processors, they can handle now the computational load of these many hidden layers. And again, this is not representative. Today, ANNs have many, many, dozens and dozens, hundreds of hidden layers with thousands, millions, and billions of connections there. This processing power requires a lot of electrical energy. And that's why data centers require megawatts of electricity. A standard AI data center is going to require anywhere from 100 to 350 megawatts of electricity. Why? To power all these GPUs, thousands and thousands of GPUs. Oh, so that's how it's done. Now, once you have the model, then comes the really interesting aspect. The model needs to be trained. This is the equivalent of learning. Let's go back to that example of face recognition. In the bad old days, we tried to find an algorithm to set up relationship between biometrics, the distance between the eyes, the shape of the nose, the mouth, the cheek, etc. We tried to specify an algorithm that says, okay, this is what a face looks like. Today, instead of telling the computer, we show the computer many, many faces, and it learns what a face looks like. We say, input, here's a man's face. Input, here's a woman's face. Input, here's a child's face. Input, here's a baby's face. Male, female, face, no face. And we do that not with hundreds or thousands, millions and billions of data sets, training data. So after a while, it learns what a face. So after training on much data, the artificial neural network is ready to generalize and determine what the input image is. Is it a face or not? Is it a male or female face? After training, it has learned how to recognize a face. Here's where we don't know exactly how it learned that and how it set the weights and the parameters of its neural network. What values and thresholds did it choose? Well, we can go in and look at that. But why did it do that? Interesting. So here's a great example of computers doing things that nobody gave them an algorithm to do. We gave them the framework, the model, the neural network. And after training, usually in a supervised way, where we said, yes, you're right, no, you're wrong, face, 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 then it was able to do the work on its own. Amazing, but unknown under the hood. Question: is this thinking? Artificial neural networks do not think, or at least they do not think as human beings do. Most AI researchers will not say that neural networks or any type of AI today is thinking. Those that do will say they're thinking, but not as human beings do. Lots of really interesting research over the last year or two showing how we believe a neural network is putting all this together to come to its conclusion. And what I find interesting, given the worldview of most AI researchers, is right now, 2025, many AI researchers are saying not only do they not think today, they may never think. Artificial neural networks are not conscious or self-aware. So this is not like human beings. They are not conscious. They're not self-aware. That reminds me, you know, I have a two-story house, and all the steps in my house are making me self-conscious. All they do is stare. Will AI have good jokes like that? Not sure. Not sure. Now, I'm pulling a sleight of hand, but this is very important to see. There's a difference between intelligence and thinking. Remember, this field is artificial intelligence, but yet all the researchers are talking about thinking. Is thinking and intelligence the same thing? Let's go back to the intelligence question. Can a computer be intelligent? Here's my answer. Yes, absolutely. Can a computer be intelligent? Yes. Now, I know some people are surprised. What? What? Here's my reason why. Today, as we've seen in other videos, computers appear intelligent. In other words, computers do tasks that if people did them would require intelligence. My classic example is you want to go buy a new automobile. So it's $35,000. You don't have that shoved under your mattress, so you need to borrow the money. You know the car is 35,000. You know that it's 6% interest. Oops, I think car loans have gone up a little bit. It's 8% interest, and you could pay back over 6 years. You wonder, what's my monthly payment? If your significant other turned to you and in a fraction of a second said $983.15, you'd say, wow, are you smart? Computers do that all the time. You can find 10,000 websites that will compute car payments, and they'll do so in a tiny fraction of a second. Computers already appear intelligent. Here's the key point, though. What makes a human being is not just intelligence. It's part of it. But what makes us human is not just intelligent. Many animals are intelligent. My dog is really intelligent. She knows exactly what I'm telling her. Now, whether she does it or not, it's a different story. But she is intelligent, to be sure. I want to tell you about one aspect of computer science known as information theory. Information theory is one of the foundational pillars of informational sciences like computer science. And what information theory says is information only comes from intelligence. Information only comes from intelligence. Or another way is, if I have information, I can produce intelligence. Well, you see, computers produce information. So we know intuitively that had to have come from intelligence. Now, yes, for algorithms, the intelligence behind that is the human programmers and also the human users. But we've just seen that sometimes computers can develop their own intelligence in the form of an artificial neural network and answer questions they haven't been told, just trained or learned. This would make sense, wouldn't it? We would expect that those things, those tools that intelligent human beings create, would possess an image of their human creator. Human beings are intelligent. You read a good book. You recognize the intelligence of the author through that information, the words on the pages. We have a computer system. We would expect it to reflect an image of its human creators. This word image is critical. And yes, I'm using image in a biblical sense. I needed a better picture. The contrast got washed out a little bit. You may not be able to tell. The pretty one in this picture is my wife. You may not be able to tell where we are. Here's a hint. We're in Millennium Park in Chicago. And this is a piece of public art. It's called, everybody calls it the bean, that kidney bean shaped structure there. The artist called it Cloud Gate. But you know, hundreds of people stand in front of it, take their picture, etc. What you see reflected on the highly polished aluminum of the bean is not you, but it certainly reflects some attributes. Whether you're pretty like my wife or rugged like me, there's a good term. Yeah. But of course, that reflection isn't us. Computers reflect some intelligence of us, to be sure. So, can a computer be intelligent? Yes. Even if it turns out they never truly are, they certainly appear intelligent, and they fooled more than half the people. This is my segue into worldviews. Not all AI researchers approach the discipline with a Christian worldview. Many approach it from a naturalistic, materialistic worldview. One of those is Marvin Minsky. Marvin Minsky was there at the beginning of artificial intelligence. He has a famous quip. Oh, his worldview is decidedly non-Christian. He believes that, well, let me show you his quote. This is his famous quip. The brain is a meat machine. Now, what did he mean by that? He meant the brain is just a computer made out of meat. Nothing special about the human brain. The human brain developed naturally over time. The flaw here is there's more to human beings than just their bodies and brains. And by the way, to say the brain is just a computer made out of meat is to totally miss everything. The brain isn't just a little more complex than other systems that we know of. It's immensely more complex than other systems. The human brain is a marvel of engineering design. Did the brain develop naturally via evolution over eons of time? Or was it created supernaturally, instantaneously by an omnipotent mind? Think about it. The intelligence necessary to understand the brain and attempt to model the brain using an artificial neural network demonstrates that the brain is a product of intelligent design and not natural processes and random events. The worldview of AI researchers profoundly affects their work and their ultimate goal. This month, April 2025, groundbreaking report. Scientists map unprecedented detail of connections and visual perception in the mouse brain. What you're seeing here is something smaller than a grain of sand, greatly magnified. It's the neurons in about a 1 millimeter cube area of mouse brain. Mouse brain. And it was genetically engineered to fire based upon visual stimuli. And then that was artificially colored. So can we figure out what's going on here? In a massive scientific effort funded by the National Institutes of Health, your tax dollars at work, hundreds of researchers have helped to map the connections between hundreds of thousands of neurons in the mouse brain and then overlay their findings They're firing patterns in response to visual stimuli. Wow. This tiny bit of a mouse brain has 86 billion neurons. See, the brain is not just a little more complex. It's not like saying, oh, a smartphone is more complex than a calculator. Brains are in another dimension based upon anything that we know and understand. It's another dimension of complexity. By the way, do you suppose if we started calling the human brain an app, that people would start to use it? How can a Christian worldview help us navigate the workings of artificial intelligence? Should we use it? Should we avoid it? How should we use it? Human beings are not just material. This is what separates the Christian worldview from the worldview of many AI researchers. We're not merely material, natural things. We do have a body, but we also have a soul. So in a Christian worldview, you can't talk about human beings, and you can't talk about human intelligence without talking about both body and soul, brain and mind. Human beings are not just material. Genesis 2:7. Then the Lord God formed the man of the dust from the ground and breathed into his nostrils the breath of life, and the man became a living being. Breathe, the word for wind, that's the idea of the spirit. God fashioned the body out of actual material. But then those neurons weren't all there was. Breathe into our nostrils the breath of life. Paul reiterates the fact that we are not just material bodies in his letter to the church at Thessalonica. Now may the God of peace himself sanctify you completely, and may your whole spirit and soul and body be kept blameless at the coming of our Lord Jesus Christ. While the brain is composed of material, people are more than just their physical bodies. The mind does not somehow just spring forth from the neurons in our brain. We have a soul, a spirit, in addition to our body. Any model of human intelligence, any model of thinking, which is an order of magnitude above intelligence, must consider both the body and the soul. It's the Holy Spirit that forms life and gives human beings their attributes. Isaiah, thus says God the Lord, who created the heavens and stretched them out, who spread out the earth and what comes from it, who gives breath to the people on it, and spirit to those who walk in it, body and spirit. Ecclesiastes, the dust returns to the earth as it was when we die, but the spirit, which is a real thing and separate from the material stuff, returns to God who gave it. A Christian can and should view AI as a useful tool. And at the same time, we need to be cautious because, as with any technology, AI is not neutral. So, how should we approach AI? As a Christian, I'm going to encourage you to approach it with hopeful hesitation. We're going to jump in and embrace everything? No. Is there some potential? Absolutely. But we must understand both the technology, at least at this level, and the worldview of its designers. We have to understand the technology and the mind and soul of its designers. You say that's hard. It is. But using our God-given abilities, our rational mind, and our discerning soul, we are able to do this. So we can approach AI maybe by following some of the words of the Apostle Paul. For the word of the cross is folly to those who are perishing, but to us who are being saved, it is the power of God. For it is written, God speaking, I will destroy the wisdom of the wise, and the discernment of the discerning I will thwart. Where is the one who is wise? Where is the scribe? Where is the debater of this age? Has not God made foolish the wisdom of the world? For since, in the wisdom of God, the world did not know God through wisdom, it pleased God through the folly of what we preach, Christ crucified, to save those who believe. For the foolishness of God is wiser than men, and the weakness of God is stronger than men. Thank you so much for the opportunity to share these thoughts and ideas with you. And I'm going to ask a favor of you. Please give me some feedback, questions, comments, concerns. This helps me figure out what's happening also. Psalm. And they, those who hate God, and they say, the Lord does not see, the God of Jacob does not perceive. Understand, O dullest of people, fools, when will you be wise? He who planted the ear, God, does he not hear? He who formed the eye, God, does he not see? He who disciplines the nations, does he not rebuke? He who teaches man knowledge, the Lord, knows the thoughts of man, that they are but a breath. Thank you. I've appreciated this opportunity to share my thoughts and views on artificial intelligence. And my hope and prayer is this has been beneficial and helpful to you also. So again, I will ask, I am coveting your feedback, your comments, your concerns, your questions. Have a great day. Until we meet again, God's richest blessings. Take care.